This is read code question number 329, longest increasing path in a matrix. This is hard question. Let's get into it. Given an index matrix, find the length of the longest increasing path. From each cell, you can either move to the forward direction, left, right, up and down. You may not move diagonal. Do not move diagonal. Move outside of boundary. Cannot move outside. Okay. How gonna solve it? Okay, let's start with the blueprint solution. Blueprint solution, first I will iterate the whole cell of matrix one by one. From here, when I meet here, I'm looking for the is that any bigger? This one? No, skip. This, so it has value 1. This one also has value 1. This time it able to go in here or here. So 2. This time it going to only up. So 2. This one, 2, this one, 1, this one, 1, 2, 3. And then this one, 1, 2, 3, 4. And then this one, 1. So at this time, the biggest one is 4. Does this make sense? Okay. At this time complexity is not linear. It must be n square. So now okay, let's make the better solution. Okay, do you have any idea? Yes, that's right. We can use memorization. Yeah, so this one we can also solve with the DP approach. So today I'm gonna use memorization with the DP approach. So my approach is, first I will use the bottom up approach. So when we move here, I will use the bottom up. So I will looking for the smallest first. So in this case, this one is the biggest one. So I will looking for the smaller here, and then going to smaller and smaller. When I reach 1, I paste this one depth is 1, and then when it popping, this one is 2, this one is 3, and then this one is 4. So I will store number 4 to the DP table. So now we make 4, 3, 2, 1. Okay, let's go to next. This one I have to go to here 4, or I have to go to here 6, right? And then cannot, and then 6, and then 1. So in this time I can, so the maximum is 1, 6 is 2, and 9 is 3. Because this one is the 3, and then this one is 2. In this case, this one is 1, and then this one is 2. So in this case 2 is bigger, so I will use this one, bigger one. And then this time there is no small one, so it is changed to, this one is already calculated, so I will skip it. This one is already calculated, I will skip it. And this time, let's check the going to 6 or 1. In this case, this is only 1, and 6 already has 2. So I will use this one, so this one is 3. Now left this one is the smallest one, so return 1. So after that, I will choose biggest one. In this time, let's check the time complexity. First, we need to traverse all cell of matrix, so it take n for traversing, and then while we the DFA traverse, it just touched only one cell of matrix. So finally, it take n plus n. N is for it scan whole matrix, and then this one for DFS. So this is finally to n. So we can say this is the linear solution. And then space complex is also linear because we use the DP table. Does this make sense? Okay. Let's implement it. So first I will make the cache. Cache is filled with 0, and then okay. Let me make n and m first. N is length matrix, and n is length matrix 0, and then cache is m multiply n for in range n. Okay, and then I will make the new DFS, and then this one is row and column, and then it will return maximum path length. So I will return, okay, let's make this one first. Then first I will check from cache. If cache has row and column, I just return column. And then if not, I need to calculate the cache row and column must be add 1 plus, because when children is the one is smaller than me. That's right. So this one is for small the children. So me is always 1 bigger than the children. So in this case, did you remember the matrix? In this case, this one is 1. So in this case, children is only here. So this value is 1 plus 1, right? And then this one also 2 plus 1, 3. And then this one finally 3 plus 1 is 4. And then in this case, it also needed to, okay, let's check with which one. Okay, 1, and then this is 2. And in this case, this is 1, this is 1. At that time, the left child has the path length 2, and then this is 1. So in this case, it select the maximum number between children. So this one is 3. So I will use same way. Max between the children. Children must be depth row and column, and it has, if row is smaller than m minus 1, and matrix row and column is smaller than matrix row and column, else return 0. Because 0 is the smallest number, if this row and column does not satisfy the in boundary, or the children is the bigger than parent, it will return 0. So I will make the 4 direction, first, second, third, first, and then first I will increase row first, and then column, and decrease column, row, decrease column, and then in this row, okay, this is check out of boundary, column must be smaller than and minus 1, and this one is bigger than, must be bigger than 0, row column also bigger than 0, and then this one is this one plus 1, children is plus 1, and this one is minus 1, minus 1. Okay, and then after calculating it, and then I will return cache row and column. Does it make sense? Okay, let test a little bit. Now we start here and it going to here, right? And then going to here, and then finally going to here. When it stay here, all of the value is the bigger than this one, right? So in this case, this one return 0, this one also return 0, this one also return 0, and this one also return 0. So maximum between 0 is 0, right? So that, and then now this one dp value got 1. And then after that, they return to here, position here. In this time, children, max children is 1, so it has 2. So in this case, the children is 3, so it has 3, and then this one is 4. Does this make sense? Awesome. Okay. Then now the cache is filled, and then I will return the max value between the fs allowance column and for log in range M and for column in range M. Okay, let's check the code. Okay, looks good. Oh, I forgot the error handling, educated handling. Okay, if non-matrix or not matrix 0, I'll return 0. Don't forget edge case handling, okay? Oh, typo. Okay, looks good. Okay, thank you.